Welcome to Science Spectrum with Don. This is the fourth part of the third lectures in measurements, measuring instruments from course code PHY 187, which is the fundamentals of physics. Alright, so from the previous class, we figured out how to report a single value, which we call the mean value, and of course that could be likened to be the true value of several measured values. Alright, now I'm particular about reporting the errors in our measurement. So how do I report the errors in our measurement? Alright, now to report the errors in the measurement, I'll talk about what we call the absolute error. Absolute error. So what it simply implies is each of the measured values have their errors. And of course, the absolute error is simply the mean error, the mean value, which we got here. So it is the mean value minus, of course, the measured value. Alright, so the mean error, I could denote that with a delta A. And of course, I could stick in two particle bars, which implies even if I have a negative term out of this, I could only pick out the positive value. Alright, so we get started. So to start off, I would take the mean value, the absolute error of each of these values. So the absolute error in the first value would be the mean, that's 2.626 minus the first value, that's 2.620, and of course they are all in centimeter. And of course this will boil down to be, this is 26 minus 20, that's a 6, so this is 0.006 centimeter. Now the absolute error in the second value would be the mean, 2.626 minus 2.625, all in centimeter. And of course this will give me, this is 26 minus 25, that's 1, so this is 0.001 centimeter. And of course you could check out for the third, the fourth, and the fifth. So for the third absolute error, the absolute error in the third measured value would be, just a moment. Alright, so this would be the absolute error, and of course I could stick in the vertical bar here to indicate that I'm particular about the positive part. So the absolute error in the third measured value would be the mean value is 2.626, of course minus 2.628, of course all in centimeter. And of course I could get a negative value out of it, but I'm interested in the positive part. So this would be just this is just 0.002 centimeter, since I don't need a minus sign, but I care for the plus. And of course the absolute error in the fourth value is simply the mean value minus then this fourth value, 2.630, all in centimeter. And of course this will boil down to be, of course I will get a negative value out of it, but I'm particular about the plus, so this will translate to 0.004 centimeter. Then for the fifth, and that's the last value, this will be 2.626 minus 2.626, of course all in centimeter, and of course this will translate to 0.000 centimeter. Alright, now the mean of the absolutes of each of these absolute errors is simply the sum of the absolute errors divided by the number of values, which is just 5. So that mean is what I would report. That the mean absolute error is the error I would report alongside the mean value I got from the measured values. Alright, so we proceed from here. So this would be, so this is the mean now. The mean absolute error would be this term plus this term plus this term plus this term plus this. But if you look at the terms, they are all to decimal places. So I could just factor out the 10 raised to the power minus 3. So this becomes 6 plus 1 plus 2 plus 4, and of course plus 1, 2, 3, 4, then I have a 0, all raised to the power minus 3. That was what I factored out. And of course this is in centimeters, then I will divide this by 5. Alright, so finally when you sum up, would get this is 7, 9. 9 plus 4, that is 13. So I have 13 divided by 5 times 10 raised to the power minus 3, because it is in centimeter. And of course, when you divide out, you get 2.6. This is 2.6 times 10 raised to the power minus 3 centimeters. And of course, the power of 10 minus 3 would imply that this 2.6 will go 3 decimal places backwards. So we'll go 1, 2, 3. So the decimal point leaves here and comes here. So what we have left is 0.0026 centimeter. So this is the mean absolute error in the measured values. Alright, so if I will report my answer, it will be, so the true value would be the mean value of the measured values plus or minus the mean absolute error, since I have several of these measured values. Alright, so the mean value, we figure that out to be 2.626 plus or minus then the error, which is the mean absolute error, that's 0.0026, and of course it's all in centimeter. This is how I could record my answer. And of course you could take the relative error, you divide this term by this, then to get the percentage error, whatever you have for relative error, you multiply that by 100%. Alright, now we move on to the next phase of this. You need to beam this up. I want to clean this in a couple of moments. Alright, so for the sake of note, I wish to move on now. Alright, now, if you recall from the previous video, we talked about errors in sum of measured values with their errors. And of course, now let's look at the difference in error. So, difference, of course, in errors of measured values. Alright, so let's take for instance, the difference, this is a measured quantity minus another measured quantity. So I could just call this x. And of course, each of these must have the error. So this plus or minus the absolute error minus the other measured quantity plus or minus the absolute error. Of course, the same translates to the difference, which is x, plus or minus the absolute error in x. Alright, so straight to the point, just a quick one. This would be the same as the difference, which we call x initially. Then we have a plus or minus the absolute error plus or minus the absolute error in the first measured quantity, and of course the second. And of course, like I said before, I'm just interested in the positive part. So this term, you see, is the same as the absolute error in x. This is x, this is plus or minus absolute error in x. So finally, x plus or minus the absolute error would just be a minus b, which is the same as x, then plus or minus the sum of the absolute errors in both quantities. This is how I would report the difference in error. Alright, you may stick in some numbers to see how this applies. So you may need to beam this for a while, and I may need to rub this up. Alright, so I give an example. Let's take for instance that a measured quantity, let's say length. I measured 2 lengths with the same instrument, and I found out that the first is, let's say 3.2 plus or minus points, let's say 0.01, let's say 0.1, and of course this is in centimeter. And the second length, let's say this is 4.5 plus or minus 0.2, of course all in centimeter. So what I'm interested in is I'm looking for the difference in the length, right? So the difference in the length of these measured values would be, so I may need to rewrite this formula. So would be the difference is x is the difference, then plus or minus the absolute errors, plus or minus the sum of the absolute errors in the measured values. All right, so the difference has to be a minus b, but I have to take into account the higher value minus the smaller one. So this would be x, which is the same as a minus b. So my x now will translate to L2 minus L1. And L2 minus L1, that is 4.5 minus 3.2. So 4.5 minus 3.2, this is a 3, of course, so this is 1.3. That's the difference in the measured length. Now, I could now stick in the absolute errors, which is this for the first measured value and for the second. So, in other words, my x, which is L2 minus L1, so L2 minus L1, I could just call that an L. So this is L, right? So L was found to be 1.3. Then the absolute errors, I could just sum it up. So this is 1.3, which is the difference now in the measured length, plus or minus the absolute error is this is 0.1 plus, then for the second this is 0.2. All is in centimeters. And of course, when you add up, you get 1.3 plus or minus 0.3 plus or minus 0.3 centimeters. This is how we report measured values with an interest in reporting the difference of what you've measured. Just subtract this, but always take note that you are adding up the absolute errors, be it for plus, be it for the minus. All right, so we move on from here. What if we have, I'm interested in knowing the products in errors of measured values. So let's take for instance that x, which could stand for any quantity, like in this case is the L. So let's take for instance that I have, let's say x is, I'm dividing two measured values, a by b, or let me start from the products. So products, errors in products rather, errors in products. All right, so I have x is a times b. So I could stick in the error here, x plus or minus the absolute error in x, and this would be the first measured quantity plus or minus its absolute error times the second quantity b plus or minus its absolute error. All right, now I could factor out the x here, and I could stick in a 1 plus delta x over x, and I have a into bracket 1 plus or minus delta a over a, then times, I could factor out the b, stick in a 1 plus or minus delta b over b. All right, I may need to wrap it up here. I will complete this in a subsequent bulletin. Thank you. You may want to like, share, and subscribe for more content.